Hi, everyone. Thanks for having me. So there's a few things that I basically want to cover today. I am an educator at heart, and what I want to do, apologies in advance if this does sound a bit like a lecture at college. But my organization, we have a problem, so it's great listening to everybody today, but our problem kind of stems from we do not take a lot of risk. We want to try and do things safely, so we do not have a lot of adoption in our organization of these tools, not the adoption that we would like to see. And I think, from some of the previous speakers, some of the things that were said in terms of psychological safety, allowing people to fail safely, that's really what we want to provide in our organization. So what I want to do is talk through my experience trying to provide that safety for my colleagues. So I'm going to assume that nobody knows what an agent is, okay? So we're going to start from the ground. So as many of you know, as we've been listening to throughout the past day or two, we started off with these chatbots. So the kind of workflow that we had initially was a single prompt, a single response. We had to copy and paste between tools. So if I wanted to write an email, I had to, copy the response from my browser and put it into my email. So this was basically the human drive in every step. We started to move away from that in terms of the tool use. So these tools, we were able to search the web. We could get them to, upload files, for example. So these were ways that we were trying to stop these things hallucinating if we could give them more and more context. So that was, that was the next evolution. What we're starting to see very recently is these tools are starting to be given agency, essentially. And what I want to explain today is what does that look like, and what does it look like safely? How can we build that safely? So essentially with an agentic workflow, it's going to be AI-powered, human-assisted. So if we look at the first one, the chat era, it was human-powered. Even when we go to the tool use, era, it was human-powered. What we want to get to really, so that we can, get the benefits out of these tools safely, is that we want the human to be the orchestrator, okay, not to do the heavy lifting. That's the key shift, is we want to go from answering questions to have a complete multi-step workflow that is fully autonomous and safe. So before we continue, there will be some new terms. So I'm sure a lot of you have heard, context windows and tokens, and there's a lot of new jargon that we have to deal with in this space. So sorry to bore you some more with some new terminology, but I need to make sure that you understand some of the terms that I'm going to be using throughout this. So an agent is just something that can take action. A skill is essentially a predefined workflow. Then we have things where we can, there's these markdown files. Like I say, I'm more of a builder at heart, so apologies. But this is a way that we can bake in our rules into these agents, our business rules, our constraints, different things. So it's essentially like, whenever you have a new employee, they don't know everything about your business straight away. You have to onboard them. This is how we onboard agents. There's this new thing called an agent or an agentic harness. So essentially what that is just a piece of software that turns your chatbot into an agent. And I will be, explaining that in a bit more detail, but some of them you're probably familiar with, Claude Code. They have turned Claude into an agent without really telling you. So we'll go through what is the agent itself actually doing. And then another one that I kind of try to avoid, but when we're talking about safety, I can't avoid MCP servers. So this, again, is Anthropic have come up with a standard. And it's basically just a way that I think of these MCP servers like universal translators. So, Gemini or Claude or whatever your flavor of chatbot is speaking its own language. So Gemini and Claude, for example, couldn't talk to each other. But if they had a universal translator that could speak every language, that's what the MCP server is. Okay, so it's just a protocol, a standard way that we can get these things to talk to other things. So the agent loop, this is essentially how we're achieving agency with these things. So there are 3 parts to the agent loop, and this is how we can change or turn ChatGPT into an agentic workflow or an agent. So this loop has 3 parts to it. You can think of it as observing its environment. It has a think about what it wants to do next, and then we can actually give it the ability to act. So, at this point, what we can do is we can start to not worry about prompt engineering and things like that. I can have a simple prompt, just give it a goal, and I can bake all of my perfect prompts to make sure that the agent is going to do what I want. I can do that in my business rules, in my agent's MD. So an example might be that, the goal is create a website or, yourselves, you just have loads of different prompts. So what it does, first of all, is it observes. It takes in the prompt, you're giving it that context. What it can do is observe its environment. So it can look at other files that are in its environment, which gives it more context, which means less hallucinations, hopefully. Then the large language model is the part that does the thinking. It's the brain, if you like, of the whole operation. And of course, we're trying to give these things agency. We're trying to give the brain a brain. So the agent, it'll take action. Once we come up with a plan, once we think about what we're going to do, then we get into the execute part. And like anything else, when does it know it's done? Well, it has to have a finish, basically a finish condition, or this is, I'm going to stop this loop now. So there has to be a way that the loop isn't going to go forever. So let's just look at a small example to see what that would look like. So a local accountancy firm needs to process 50 client invoices. They want to extract key data, update a spreadsheet, and then email each client a summary. They want to do this every month. So this would be a good workflow for agents. So this is my prompt, process this month's invoices, update the tracker, and email summaries. I have a demo that I'm going to share with you after this, and you can have a look, if you're more interested. But essentially, we don't even need that difficult of a prompt. I can just say process invoices, because all of the proper instructions I can bake into the agentic loop. Okay, so agent will use it will look for some skills that it has. So it has a file reading skill, for example, and it needs that to read the PDFs. Then it will decide to batch update, or it'll decide what do I need to do next. And I'll need to do this for every single client, every single invoice. And then it actually does what it planned to do. So it writes it extracts the information, it writes it into Excel or your spreadsheet program, and then it starts to flag or write the email. How we can connect to the email and the outside world, essentially, is through the MCP server. So we're going to have a look at that in a little bit of detail. Again, I'm very much aware this gets very technical, so I'll try not to bore you too much. I can already see there's a lot of people getting glazed eyes and starting to sleep. So if we just do a comparison side by side, the hammering will help keep us awake. So we have, if you just look at the, let's say, for example, the interaction, okay? With the chat workflow, we have the single prompt, single response. Then I have to go back and I have to say, no, that's not what I meant the first time. This is what I want. And then it's a back and forth. We're actually playing ping pong, something like that. So in an agent workflow, I basically say to it, go and do that thing. And then I walk away and I put the kettle on. I start making my coffee. I'm not going to go through every single, a lot of this is just for your information. You can look at these slides after, but if we look at the context, for example, the context in the chat workflow is lost between sessions, okay? And then every time you have to say, this is who I am, this is what my business is, this is what I want you to do. With these agents, again, we can bake that right in, and every time we come back to the agent, we don't have to fill out all of that boring stuff. It knows us. It knows our context. It knows what my business is. Again, it's like I onboarded an employee. The employee knows everything there is to know about me, so I don't need to onboard that employee every single time. These are multi-step workflows, okay, so they can become quite complex, whereas with, the chat workflow is just a simple kind of, but I'll go on because I really want to get into how do we do this securely. Okay, so hopefully that was a whistle-stop tour on what is an agent. I actually like to call them agentic workflows because that's essentially what we're doing, what we're building. So how do we do it safely? Somebody mentioned earlier about, I give an agent a task. It can go in that loop. Let's say if it's doing 50 emails, okay, 50 invoices, like the example I went through, that loop might execute 300 times if I'm lucky, okay, because essentially what the model is doing is saying, no, you didn't get that right the first time, so instead of me playing ping pong with it, it's playing ping pong with itself. So there's a couple of problems with that. In our organization, our biggest problem is data privacy. Okay, we, process students' data, so it's a big, we can't be putting that stuff into somebody else's hands. So we have to maintain control of that. The best way to do this, we found, is the local large language models. Now, you're losing the speed, but you don't have any API costs. You have complete privacy. In Europe, we have to deal with the GDPR, so it's automatically compliant with the GDPR, for example. I don't have to turn the internet on to use it, okay? So we can use these as teaching tools. It's completely customizable. And then on top of, now this is just Google's Gemma 4 model, but there are loads of these local large language models. I'm just taking this as an example. It's open source. So I can download it, I can feed in my data, and I can train it. I can, hyper-tune it and train it to just be focused on my data. Again, trying to eliminate these hallucinations. So the first thing that we need is local models. There is a trade-off. It's going to be slower because it's running on your machine, okay? But buy a bigger machine, stay safe. The next thing that we want that I do is I sandbox these things. I give them an environment that is one that I can replicate at the drop of a hat. I can, run one command, click one button, and I can have my whole agentic workflow infrastructure ready to go. So I do this with sandboxes. Now, Docker, again, brand name, never mind the brands. What I'm really looking at is the components of this. So a sandbox, which is essentially just a lightweight computer that runs on your machine. It's using your machine's resources, like your CPU, like your GPU, but it's isolated, so it doesn't have access to your file system, for example. You put the files in that you want to give access to. So these sandboxes, the other good thing about it is if anything goes wrong, you just pull the switch, right? You just kill the sandbox. It hasn't done any damage in terms of, it hasn't got itself outside that sandbox. So what we call the blast radius is maintained. I'm going to go quickly over MCP servers because this is essentially just a safe way to access the outside world from these tools. And like I say, this MCP, this protocol, model context protocol, is essentially just a set of rules. And this is how a model should talk to, let's say, for example, Gmail. But I can now plug in loads of different tools and give it into one model. So this thing is really, the agent only needs to talk to the MCP server. The MCP server is that middleman where it can talk to all of my different tools. And again, why is it safe? Because we can control that MCP server. It's one point of control that if anything goes wrong, then we shut it down. So, putting all this together, and this is, for any business, small, medium, whatever size. Like I say, I'm doing this for my organization to try and drive adoption, because I want to give them that safety of, if you fail, what odds? You're not breaking any regulatory, you're not breaking any laws, okay? You're GDPR compliant, for example. It's free after the first download. So go with a local model. This is what I tell my organization. Start with a local model, put it into a sandbox, put it into its own isolated environment. Use an agent harness. And like I say, an agent harness is just a piece of software that will make sure that your chatbot goes in that agent loop. Okay? In the demo that I'm going to share with you, you can watch it after. I'm sharing the code, and I have a video as well on YouTube if you're interested. Now, it gets more technical, believe it or not, but it's for anybody that's interested. I wrote my own agent harness because I don't trust any of them. Again, safety first, because these things are experimental tools. You look at any of the agent harnesses out there, what version are they in? What version is the software? Version 0. So none of these have actually been, battle-ready tested. So I don't trust them as far as I could throw them. Again, I can't take the risk. Then the MCP servers, again, a way that you can control what your agent is getting. What is it able to access? What is it able to do? So just kind of to finish up, this is my local, this is what I'll be sharing with you. I basically have one file. I run that script, okay, that program, and it builds this infrastructure for me. So I can start with, my local large language model. I have the agent harness, again, just a program that goes in a loop. The MCP server is there optional. I have it in the infrastructure file. Infrastructure is code. Essentially, I have it there. It's not plugged into anything. So it's an easy way for the agent to get out onto the internet. So if you look at this, the file system is completely protected. Let's say, for example, the agent tries to delete the entire operating system, which, you hear these horror stories of this happening with these agents. It can do that. It can delete the entire operating system, and it's only harming the agent harness. The large language model is in its own sandbox. The agent harness is in its own sandbox. The MCP server is in its own sandbox. If there's any element of this infrastructure, any of them components that I need to pull out and change, because somebody said it, and this is one of the most common things that you hear, the environment's moving too fast. It's moving faster than I can keep up. If you build your architecture correctly, you don't need to keep up. These things are microservices, where we can plug out one, put in another. Let's say Gemma 4 is the best local model now. That might change tomorrow. This morning I got an email to let me know from Anthropic that Claude had just updated to Opus 4.8. I don't care about that. That's irrelevant to me, because if I do have a local model that becomes better, then I just go, right, pull that one out, I'll stick the new one in. So what's the whole point of this? Your data and your file system's safe, okay? The agent cannot get to your file system in this architecture. It just can't do it. It doesn't know it. It can't see that. It can't see above or outside the sandbox. So your host network is safe. You basically give it, these are the things that you're allowed to visit, deny everything else. There's no limits to the agentic. Like I say, that agentic workflow or that loop can go on forever. So it doesn't cost us anything. And then we can access any tools just with the MCP. So I'll just finish on this. Sorry, I'm out of time. But again, this is a non-exhaustive list. I'll go through it quickly. You can look at it yourselves. But there's loads of different ways that we can try and battle harden these systems. And this is just some of the good practices that, in my experience, have helped me. So you can follow, I'll put the code up on GitHub, and I have a tutorial there, so you can go along with that demo that you can watch on YouTube. And that's everything from me. Thank you for listening.